We have a question here that says we should find the value of x and y in the figure below. Previously, in one of my previous videos, we've solved for the value of x and y using the principle of similar triangles. In this video, we are going to calculate for the value of x and y using Pythagoras theorem. So here you will find out that we have two triangles, A, B, C, and a smaller triangle, B, E, C. If we bring out these two triangles, this is what we have. Triangle ABC with the sides 8, root 13 plus y, and then x plus 9. And the smaller triangle BEC with the sides 6y and 9. 6y and 9. Because these triangles are right-angled triangles, we can solve it using Pythagoras theorem. So let's start with the smaller triangle. We're going to find the value of y using Pythagoras theorem. Y is the hypotenuse, and so the square of the hypotenuse is equals to the sum of the square of each of the other sides. So we can say y squared is equals to 6 squared plus 9 squared. 6 squared plus 9 squared. If we solve further, y squared gives us 36. 6 squared is 36 plus 81. 9 squared is 81. 36 plus 81 gives us 117. So y squared is equals to 117. And to obtain y, we take the square root of 117. 117 can be broken down into 9 times 13. So we can find out that the square root of 9 times 13 can be written as square root of 9 times square root of 13. Square root of 9 is 3, so that y will be equal to 3 root 13. And this is the value of y. Y squared equals to 117 is a quadratic equation. You can argue that the value of y is plus or minus 3 root 13. But we've ignored the negative because length cannot be negative. So the only useful part of the solution is the positive values. That is why we've ignored the negative value. So y is equals to 3 root 13. Now that we found the value of y, we can put it here so that we have 3 root 13 plus 13. And that means the hypotenuse of this triangle, the bigger triangle, becomes 3 root 13 plus root 13 gives us 4 root 13. It's just like saying 3x plus x is equals to 4x. Now we can use Pythagoras theorem again in this triangle to find the value of x, which means we'll be taking the hypotenuse squared equal to 8 squared plus x plus 9 squared. That is 4 root 13 all squared, that's the hypotenuse, is equals to x plus 9 squared plus 8 squared. This is Pythagoras theorem. Ignore this. This is Pythagoras theorem. We are not using the principle of similar triangles here, but Pythagoras theorem. So ignore this. Now we can solve from here. 4 squared is 16. Square root of 13 squared, the square will cancel the square root and we'll be left with 13. So 4 squared is 16. 16 times 13 will be on the left hand side. So the left hand side becomes 16 times 13 equal to x plus 9 squared means x plus 9 times x plus 9 plus 8 squared is 64. Let's expand this bracket. 16 times 13 gives us 208, and that will be equals to x times x is x squared. X times 9 is 9x. 9 times x is 9x again. So if we add 9x to 9x, we have 18x plus 9 times 9 is 81 plus 64. 81 plus 64 gives us 145. So we have 208 equals to x squared plus 18x plus 145. This is already a quadratic equation. We just need to move the 208 into this and equate everything to 0. So we can say x squared plus 18x plus 145. If this crosses over, it becomes minus 208 and everything becomes equals to 0 because we'll be left with 0 when this goes to the right hand side. 145 minus 208 gives us minus 63. So we have x squared plus 1 plus 18x minus 63 equals to 0. This is the quadratic equation and we're just going to find the value of x. So we are looking for two factors that when we add them up, it gives us 18, and when we multiply them, it gives us negative 63. And those numbers are 21 and negative 3. 21 minus 3 gives us 18. 21 times minus 3 gives us minus 63. So we can say x squared plus 21x minus 3x Plus 21x minus 3x is plus 18x, so we replace 18x with this. Minus 63 equal to 0. Let's factorize. X is common to both sides here, so if we factorize out x, we'll be left with x squared divided by x, we'll be left with x. 21x divided by x, we'll be left with 21, and we are done with this. Between 3x and minus 63, what is common is minus 3. Minus 3 into minus 3x will be left with x. Minus 3 into minus 63 will be left with plus 21, and this will be equal to 0. When factorizing quadratic equation, ensure that what is in this bracket is the same thing as what is in this bracket. So you can just pick one of them, x plus 21, and pick what is outside the bracket, x minus 3, into its own bracket. So we have the factors as x minus 3 in one bracket, x plus 21 in another bracket, and everything is equal to 0. What this means is that either x minus 3 is equal to 0 or x plus 21 is equal to 0. One of these two must be 0 for this to be 0. Now we can say from here that if negative 3 crosses over, it becomes positive 3. So this becomes x equals to 3, or if positive 21 crosses over, it becomes negative 21, or x is equals to minus 21. Again, x cannot be negative because the value here, length, is not negative. If you put minus 21 here, you have a negative value here, and length cannot be negative. So we are going to discard negative 21 so that our answer becomes 3. So the value of x is 3. Very simple, and I know you enjoyed this. Now try this question again. This is the question I gave you earlier to solve using the principle of similar triangles, but this time solve for k and m using Pythagoras Theorem, and put your answer in the comment section. Thank you for watching this video, and see you in our next video.